Okay, we start. So we started with method of what? The last time we met. Method of the characteristic equation, and we did linear and semi-linear. Linear and semi-linear. Linear is when we have only the u multiplying the function, and semi-linear is when we have the partial derivative multiplying the function, or both u multiplying the function. If it happens like that, it means it's a semi-linear. In fact, even though how to solve it, they all work with one method, but yes, still you have to be able to identify it. Okay. So we are done with the linear, but write this one down and solve it later. It's a linear equation. In fact, we have to be working more. S squared there are some questions that if we open it, alright. Because please, what type of equation is it not linear? What type of equation is that? Is it linear or semi-linear? Linear and semi-linear, which is which?
Semi-linear.
It's semi-linear.
Because the dependent variable is not constant.
Yeah, the dependent variable is not constant, so it's semi-linear. And we are not semi-linear, so we should be able to solve this. Alright. Forming it after what you are going to do today, you can go for it. So just write it somewhere. Just find the general solution for it. Yeah, the general solution. So write it down. After today, you will be able to solve it. But it's a semi-linear, and you are done with it. Okay. So let's start with solving quasi, like I'm mostly saying, solving quasi-linear PDE using the method of characteristic equation. And the truth of the matter is that the method only works up to this type. It only works up to quasi-linear. So here we are using the method of characteristic equation. All right. Okay. But before we start, I want to establish. I want to lay emphasis on something. The first thing is the algebra that we're going to use. The algebra. The algebra is that A over B is equal to C over D. And if this is true, we can issue an equivalent statement. That then it's going to be A plus C, which is over B plus D. So when we write it this way for you, so when we issue the equivalent statement, it will be equal to C over D. So we are saying that if this is true, then this is true. With variables you will down. So let's pick any value. With variables you will down. So let's pick any value. You can pick any value. You can say that A is equal to 2, B is equal to 3, C is equal to 4, then D is equal to, let's say, 5. Try it and see. Let's try it and see. Here is not a problem, but here. A plus C. What is that? A plus C. 6. Very good. B plus D. 8. Is it 8? And we are saying that it's equal to C over D. What is C? 4. What is D? 5. Is it the same?
No.
Is it? This one we go to. Four. They are 4. Is it 3 or 4? 3. Ah, okay. Oh, then sorry. But this one is the same thing. Okay, then you give me any example.
I think
with this, let me use class of
I think we should choose numbers that will divide it on
Yeah. Please, what number when we divide by this? Because this and this. Is that not yeah. So, example like.
Let's just use the first one.
Okay, 2, 4. And this 2, 4 is the same as 1, 2. Yeah, sure. So, what this means is that A is what? 2. B is what? 4. Then C is what? D is what? So, let's go do that substitution. Yeah. And this is plus or minus. You know it's plus. It's plus or minus. Quickly, let's. A plus C. 3. B plus D. 6. What is C? C is what? 1. What is D? 2. You agree now? Alright. So you have to base on this condition. I think it's okay. Alright. So in our solving, we will be using this algebra. That is why we need to reflect on it. Again. If you have dx over, let me say dy over x plus dx over y. If you have something like this, don't forget, in exact differential equation, depending on both, in case you forget, you can go and watch it on YouTube. I prove all the formulas, I prove all the equivalents. And the idea is that if you have x and you differentiate, you get dx. If you have x and you differentiate, you get dx. And if you have y and you differentiate, you get dy. That's how it is. So if that's the case, then this, we can write this in the form. In fact, we are going to be using some of these things. You can write this in the form like factoring d out. You see, like that idea. This will be the same as the differential of y plus x over, then this will be s plus y. So anytime you have something like this, we can combine it. That's what I mean. Is that always clear? We can combine it. And when you combine, you integrate. That's really the exact. But the idea of using the exact is the same as integration. You integrate. So let me ask you this question. If you are to integrate this, what will you get? Maybe the one about. With respect to what? I don't know. That's the question. So you have to know what is respect to. Is that you are? But okay, we can rewrite this in the certain form. What is that? Can you rewrite it? So that you see where you are integrating as respect to well.
Yes.
Can you see? Please, can you see that it's the same as 1 over s plus y, and we are integrating this as respect to y plus x, or y s plus y, the same thing. And please watch. What is here is the same as what is here. True. True. The function we want to integrate, this one, is the same as this. So in that sense, it will be the same as integrating 1 over a dA. What is this? Linear. So integrating this is the same as integrating this. Clear? Clear? Please, I hope you can see it. We will be meeting it too. It's clear. Alright. But it only works when this is equal to this. Then you sharpen it. So this will just be ln of what? S plus 1.
Lane and not delane. Delane or lane?
Lane. Lane. Okay, we go, like here, we get my
No. If God said delay, then it means that not being integrated.
Yeah.
You have to be integrated. If you say later, it means you have integrated. You will be able to understand.
But like for here, we get my for here. Okay. Another way, if let's say you want to integrate s plus y or s minus y, what will it be?
X minus y all squared divided by 2.
S minus y all squared divided by 2. Do you agree?
Yes.
You agree? If you don't agree, go for this. It will, in fact, we are going to repeat this thing. That's why I'm doing that. Because what we are integrating respect to is the same as the function. So it's like this.
So it means now the operator is
Yeah.
two variables.
Yeah, the operator is two variables. But it's not even, the focus is not even the two variable whatever.
How it goes.
What we are integrating is the same thing we are integrating as respect to. So it's the same as this. When we are going to write a squared over 2. Or if it is x, dx, you write s squared over 2. So now we can see that. So now I can go forward to what we are going to do for today. So let's quickly move on. Let's quickly move on. Quick. First question. Solve the PDE. Solve the PDE. But the moment you see the question, analyze it. Please, is it crazy?
Yeah.
It's crazy. I want it crazy. Okay. Okay, so let's see. So what the first thing to do? What the first thing to do? We are using the method of characteristics. We identify our A, that is s y squared plus u. Then the B will be very negative. y. Then our f will be everything. Now, please here I will advise you the method of characteristic equation. Is this dx over a is equal to the y over b, which is equal to the u over what? F. But like I said, I told you the other day, I said this dx is the same as over the t. This over the t. This over the t. This over the t. They are over the t. By the end, we don't write the t by this. When you are solving quasi-linear, you need to be bringing it. You need to be bringing it. So let's take a look at that. So here is going to be the x over the t. It's going to be over y squared plus the y over the t is going to be over negative equal to the f over the t. The u over the t will be equal over u x squared minus 4. Then we continue. Here we are going to form two OD. Alright? But in the forming, now let's check from what you know already. When coming from linear, can you use that? Can you just say I'm breaking this today? And so, or that. It will not work, right? It will not work. So, since that will not work, we all have to do certain analysis. So let's watch what is there. Looking at what we have there, please, how we are all looking? Yeah, we all have to. Looking at what we have there, can you see something? What is the problem that when we equate this to this, we can't work? Is it because of the u? When we equate this to this, because of the u. Because of the u. Because of the u. Yes. And if it's because of the u, then watch. Without this x and without this y, knowing that this negative will affect the inside, right? Or we can say that this negative will affect the inside. Yes. So without this and this, here will be negative u. Please, I'm taking my time here because it's very critical here. Here is negative u and here is plus u. So when we add, would the u go? Yes. Would the u go? Don't forget the equivalent statement that we issued. Since a over b, which is this over this, is equal to c over d, which is this over this, then we can do what? We can add or subtract the numerators and the what? The denominators. Please. I always clear. Alright. So, hey, I don't know. X, I don't know. But put me clear this if you was I was able to apply. Let's try and kick it to the top there. From the denominator to what? Numerator. So what is going to happen? What is it going to happen? Don't forget that here is something like Here is something like x over 1, right? So the inverse of x over 1 will be 1 over x. So we can write 1 over x on top there, and it's the same thing. Yes. So the 1 over x over 1. 1 over x times. You see that? It's the same thing. So, please, I want to know the reason why I want to subtract this from this and subtracting this from this. I want to know the reason why. Because I'm saying that if we subtract, since minus is here, we are adding. If minus is not there, you have to subtract. If we add, the u will go because the u is creating the problem now. Here we can write it as 1 over x dx what? dt over y squared plus u equal to 1 over y dy dt. All this over so negative help me x squared plus u. Please watch it here. When you like we have equated this and this, right? But we can't work it with this because of the u. So we have to apply the algebra. And you know that the algebra, you will agree with it now. So we have to apply the algebra that, let's bring up the u over dt. Yeah, the same way. 1 over u. Yeah, the same way. Bring that.
Minus
Y. Okay. So from here, we want to use the equivalent statement. Forget about this. We are using the equivalent statement here to add the numerator and the denominator. These are always like. And the reason is that CJ. And the reason is that we want the U to add to go up. So now we can add this. What is that? Y squared plus u. You can even forget to be minus s squared minus what? U. What is happening now? And it will be left with what?
Y squared minus s.
Very good. So watch. 1 over u du over what? dt. I'm copying this. Who is not okay up to here? It's clear. Alright. So now we know that this will cancel this. So it's going to be left with 1 over s dx dt plus 1 over y dy dt. All this over y squared minus y squared minus. But what do we have here? So we have to manipulate so that we get the same as this. And when it's happening like that, you know that we can cancel it out. Having the same denominator. In case you maybe you guys see them like this. See, here is s squared minus 1. Now, I know that here is y squared minus what? S squared. But since a over 2 is equal to b over 2, this is the same as a is equal to b, true or false? So if you try to make the denominator to be the same, the work will be simple for us. Please, I hope you can see it. So, even though here is y squared square minus what? S square. But let's factorize the negative out. So when you factorize the negative out, the S is negative, right? So that will come here. It will rather now become what? Positive. Positive. You see that? Then minus what? Multiply back, you get the same thing. And now, this negative will go top. You get it? So we can clear off the what? The denominators. Since it's of the same thing. Or you don't have to apply the algebra that let's multiply both sides by S square minus Y square. So that we see that it's cancelled. You agree now?
I also manipulate the second function.
Which one?
For the
The one on your right. The one, so that one.
So that, but if only you know that this negative go and pay the all, everything here.
To multiply two functions, but that was to one.
But how do you get what you want to forget?
With the factorization, it comes then at here or here.
It can say, yeah, just knowing that because you are a mathematician, so knowing that negative is coming here, it's going to affect everything. Well, if you want us to do it, no problem. Alright, so we can maintain, since you are having the concept is what matters. So y square minus what? S square. So if you want us to manipulate this to get the same thing, no problem. The negative come out, what will you get? So you get what? Y minus y square plus what? Minus S square. Because now the here will be positive, here will be what? Without the square. Any of it is the same. Any of it is the same. They don't come in the video that. So you right. Listen, can I go here? Please, I'm repeating again. Whilst writing, listen, it's very important here. And once you grab it, the rest is just simple. We follow the same principle or the same concept. The idea is that after setting this, you all know how to do this. If this is here, bring it here and do it. Alright. After this, check it critically. This, even though all the equity we are working, but let's look at this. This and this. Can it work? This and this. Can it work? From what we have done. Check. This and this.
Yes.
Go that way.
Yes,
Are you sure?
The S square, okay, see. So you mean that if you make here 1 over S here, then here 1 over S, I hope that's what you are trying to say. Sorry, 1 over U. But here will be dy, here will be what? Du.
Yes.
And when we subtract, what will go?
The S will go.
The S will go. So it will be in terms of U and what? And what now we have what? Du and we have what? You are getting what you want to project. Obviously you are getting it. Yeah. It will work. So this will be in terms of 8 what? Function. And this one will be in terms of over F function. This is just it.
Copy. But for here, anything is technical.
Please, yeah, what we are doing here is it? Yeah, it matters whether we take it, but if this Accept.
When you push the X underneath and the Y up and add.
When what I do that,
Push the X, Y,
we push the S and the Y up. This one, sorry, this and this.
yeah, we are adding this and this.
This and this.
No, this and this.
This and this.
First.
Oh, okay, I want that one here.
We are going to the first and second.
We have already done that. We have so this option is out now. This and this option is out. So now it's whether this and this or this and this.
Or you can take the two and do an operation with it.
Yeah.
Close to this.
That's what I'm saying.
They are supposed to create and destroy.
Please, are you not right to do that calculation?
No, sir.
We do that and add the first
So you are done.
or second one.
Yes.
So
Like you be analyzing it that way. That's how they think.
And how I create these two, I can also get in terms of where it's going.
It can even be that when you do the analysis, it can even be that it's as if it works, but when you try something, you always have it will not work. So that's why I don't want to talk there, but it was just analysis that we're doing. It's very good. But you see, let's move on to finish. Now we have to OD, so let's go and solve before we come back to it. You come back to it and analyze it again. It's good that you're able to bring that assumption, but it will not work. Please, can I clean it? Can I clean it? Okay. This type of question. In fact, let's move on. So now here, everything goes. So 1 over x, ds, dt, plus y, 1 over y, dy, dt, equals to negative 1 over u,
The U over the T.
Clear? Okay. So when you read this part, it's just simple. This is how you're going to do it. And that's how you do it. When you read this part, you are just going to take integration now. You are just going to take integration. It's an exact, but the sharper way is you are taking integration. That's all. But when you take the integration, the results will be in terms of the d dt. The operator will come. Here we are taking integration, so we are going to do it's exact. But sometimes by that you can forget it. But the easiest way is that. What is this? What is this? 1 over x. Integrate. What will you get?
Yes.
You will not show the integration sign. You won't show anything. This means that it is d dt of ln x. This is the explanation, and it's coming from exact. And I'm saying that in case you are forgetting your exact, don't worry. What is there? The function. Focus on the function. The function is what? 1 over x. Integrate. You get what? Ln x. So d. That's why when we were starting math for doing the question, he will come up and say that place and this one live with it. The same way, what is 1? It's 1 over y. That's what you can see, right? 1 over y is what? Leave what? So d. Please don't bring the s again. Get the d, like the derivative of. Like it's like an implicit function. Okay, it's like an implicit function. So the t, then this will be what? Ln y. Equal to the same way. Take ln of this.
Negative. Negative line.
Negative length.
U.
Negative ln u. If you want to ignore the negative, you write 1 over u algebra. So many today you are I can see that you are doing. So yeah, this will be now see in case this negative girl will disturb you, in case this negative girl will disturb you, send it to this side. If this will disturb you see that in case it will disturb you, so that you can blast. So here will be the t. Just integrate it, and that is ln u equal to 0. Please, I always clear. Now, watch. Any emphasize again? Or I should move on? I should move on. Yeah, we are integrating, but we don't write. We don't write. Okay, so from here, we have d over dt, d over dt, d over dt. So why don't we factorize out? So you can factorize d dt out. What is this? What is this? Then go and apply what is Go and apply your algebra. But don't forget. Okay. Then now you go for your algebra. This is just algebra. The inside. Go for it. You. Go.
Can't we simply divide it by dt and then get the next one?
No. If you do that, you get it wrong. The reason the d will go alright, but something is going to happen. Are you getting what I'm saying? Now that we have it, let's make it a single function, and I will tell you something. But from here, it's the algebra that's why you want to run away. I think it's positive, so just multiply them. Plus and so here it's u x, y, z. Like this. U. Oh, x, y. Equal to integrate those sides so that you can remove the what? The d there. Yeah. So this time around we integrate both sides. As respect to dt, as respect to so integrate both sides. But when you integrate them, what will you get? So please here you integrate them, you get ln s y u equal to c. But this will be don't forget that the question I just solve the one side. We just the one side we are solving. We haven't come to the other side. And they are still on the one side, so this will be C1. Oh, it's not because I just don't want to grab things.
You need the concept. You need the concept.
Yeah, the concept is 1%. So, yeah, so from here, what do you do? It's not difficult. The physical part, the only physical part is forming the OD. After forming the OD, you go when you come to this, when you get to this side, just know that Here we are integrating the function, just like that. Don't write any integral there. Just differentiate the integrate the function, write deep and bring that there. Because if you are to go and remind yourself of that equation, so integrate, but keep making the that. And when you get to this side, here show the integral sign because we are integrating both sides. Please always clear. Alright. So here, please, you know that no matter what this is, it's still a constant.
We should have left it.
This will cancel this one out. But E is a constant, C also is a constant, so it's a constant. So therefore, C1 will be equal to X, Y, 2. You can then meet equation 1 or whatever. Now we are going to look for C2. It's the same concept. Now we are going to look for what? C2. So, let me go and rewrite the thing again. Let me go and rewrite it. Let me go and please, can you all see from here? Can you all see from here? Alright. So, to get C2, yeah, it's master, so we take our in fact, if you don't go through these things tomorrow before you go to class, you will see everything. Please, I hope that the equation. So now we are done with C1, C2. Like sir, you raised a certain suggestion that we are to again, so that we in fact we want to combine all these because those are the things that will be popping up in your mind when you have certain question. And let's see if it works. The last two, this and this. No problem. Okay. So what do we do? What do we manipulate? The express. So we should do the same way, right? By writing 1 over this, then 1 over the u of like 1 over this, then after that we subtract. We will still add because then we add because of this negative. So that the x will go. But see, when that happens, don't forget that after everything, we are going to equate it to this side. Do you know that? You are saying we are adding this side, right? But after that, you go and equate to this. What it way? Thinking it only this way, you may think it away. But when you go and check this side, you don't know. Because when you do it that way, the x will go all right. And what will happen?
I said, yeah, so we get u and y squared as the denominator for the side. And this side we have y squared and u.
Let's try it. Let's try it. No, I don't want to be spoon-feed. I don't want to go straight to what I want to do, but let's try that view and see. We are getting it. Alright, let's try that view. Alright. So what Sir is saying that we should maintain this side. Let's try it. Then we are, right? So dy dt plus du dt. So here is over what? Y. Here is over u. Then this negative will cancel this, right? We are adding. We are adding. We are adding. So the x will cancel. So it will have negative u minus y squared. And here too, I'm sure you want us to do it this way.
When you factor negative.
So when we factor the negative out, okay, 1 over x, ds t over y squared plus u is equal to so here y squared plus u, then the negative should go to the okay, but it will affect the whole of the inside. Like if you don't have any problem to you can negate both sides so that the negative will come here, like what you suggested. So here we can negate both sides, right? So that the negative will come to this side. Please, let's check if everything is correct.
Cancel out.
Where shall we?
Denominator.
The denominator y squared
Y squared plus
which one? This is what please we are discussing what should we do? Please, is this one the same as this? What we want to apply? Is it the same as that? Is it the same as that? Okay. Now, let's go and check something. Go and check. I know now you know that these ones will cancel. Check the numerator here and the one we have. What is the difference between it? The one we have to get C1. Check. What is the difference? What is the difference between this? Now I hope you know that from here, yes, it's we can negate both sides. This negative will come to this side, all right. This and this will cancel, all right. So we are going to write 1 over x dx dt is equal to 1 over y dy dt plus 1 over u du dt. But don't forget, we have already applied this concept in working with this and this to equal to this. That we had C1. Is that not so? So if you try to apply that same thing, even though you're not taking which one? The focus I want to even push is that the idea we use to get this, isn't the same thing that we apply with the C1, true or false? So now check what we have before saying that integrate. It's not the same function. So you are going to get the same C1 again. Okay. Oh, you will check. It's not the same thing. I want you to follow so that.
The negative is now affecting the numerator of that particular fraction.
It's still the same thing. If it's affecting this, can't you negate both sides?
So, this is compulsion that when you get when you get you should put everything at one side.
Sure. Yeah. That one. Even if it is not compulsory, if you don't take
because this one, because it's not compulsory, then you can take it like this and get.
But yet it will be the same thing. See, because after the integration, you add C. You add the C after integration. And then you see the constant C can be negated or not negated, it's still a constant.
But with this, when you integrate both sides, you don't put them at one side. When you integrate, you get the x to at one side of the equation, and the y and u and c at the other side.
No matter what, if you apply algebra, you get the same. So let's get this
What
straightforward.
he is trying to say is that if they are at one side, the x, the y, and the u are at one side, in the process of bringing them to this side, they will become negative. Is that what? Okay.
And what I'm saying is, if you maintain it like that,
See, you know, when you go try it, you apply the algebra, you get the same thing.
You're back to square one.
Please, how you are getting what I'm saying? So that concept, after applying, you can't apply it again. You have to go for another one. The fact that that one work for this and this doesn't mean that now you're going to use the same thing for this and this. You get the same thing. So I try to add his concern because you may try to do that one thing and you get the same thing without respect. So let's go for another concept. Please, I will explain. All right. So now we have established. It's good to accept the views and address. Okay. So we are going to apply another concept for us to go and find the C2. So now let's see something. Please, I hope you are watching. Please, I hope you are watching. Once you get this, the rest they are similar. The same concept applies to. The S squared here. If I multiply this by 1, I hope it will be the same as this. Then to multiply this by 1, that will be the same thing. Why don't we make it S over S? The reason is that. Please, I hope you are watching. The reason is that I want to multiply this by 1. And multiply this by 1 will be the same as S over S. I want to apply the same S here to this so that I get S over S. Please, I hope you are watching. What are we going to get from down here? S squared, Y squared. If you try to expand, you get S squared, Y squared. That's the focus. S squared, Y squared. And US squared, yeah. But the focus is S squared, Y squared is going to be generated. Let's watch here. Here we are going to multiply it by S over Y. S over S. What is this?
Y.
So if you multiply this 2 by Y over Y, we are going to get Y squared. Please help me watch it. And when you apply, you get what? S squared, Y squared.
And why are you multiplying by?
Yes. Another algebra. You know that the first one is algebra. You know that the first one is algebra. So we want to go by another algebra approach, whereby we won't change the question, but it will work for us to get C2. It's algebra. It don't change the question because multiply it by 1 is still the same thing, but it will change the C2. It will change the what? The C2. Please help explain. All right. So let's go by that. So after that, when we add, because negative is here. When we add, you see what we are going to get. If it will be the same or not the same. So now, we are going to get S. So here, don't say 1 over. We are not using that. So S ds dt over what? It's going to be S squared, right? And that S squared is multiplying Y squared. I don't want us to do it straightforward. You let's break every step. Later, when you form the concept, you can do whatever you need. Then here too, we are multiplying it by what? Y over Y. And here you get Y dy dt over negative Y squared S squared plus U equal to
U.
No, that part is not the focus. Just the same thing. The reason why, see, we want to form S squared Y squared so that when we add, it will cancel. Can you see it? We want to form S squared Y squared so that when we add, it will cancel. Because here, if you try to make it U over U squared, it won't do anything. Wait, help us to do something.
But I think whatever that you do here.
No, but it's algebra. Algebra. This is multiplied by 1. This is multiplied by 1. It doesn't matter. You don't change the question.
Yes, I'm changing anything.
It oh, interesting. It don't change anything. Please always correct. It don't change anything. But that place.
But when I want to ask you.
Okay, ask.
So one question with all these minds, we are suffering like that.
I don't want to feel with you.
Okay, let's go.
So now, after applying this just coordinate, this just coordinate, go by it. Let's go by it, the same approach. Now make it easier so you can add. Let's see what is going to happen. So now here, S ds over dt. I hope here is plus. If it's not plus, we will subtract. You know where that we are. So here, y dy dt, the whole of this. Beautiful. So this will be x squared y squared plus s squared u minus s squared y squared. Please help me watch. Minus u y squared. What is happening? What is happening?
S squared, y squared.
Equal to du dt over here. You can write the same thing. Now, watch. Please, look at something right now. Look. This will cancel this, right? And if this cancel this, and you can, I'm hearing it. You can factorize what? 2. In fact, now what Abba saying you can factorize it, then we done God. We can factorize u and to be the same as this. Please, I'll be here. You are getting this. This, in fact, let's clear. So now, this and this, you can factorize it, and you can get the same as this. If this first example, that's why if you are having a long way by the same approach, you won't get anything. I say you are one is positive. Which one? This. Everybody you can factorize. It will be. We can factorize. Oh, it will be. So yeah, you get s ds dt over what is that? S squared u minus yo, we have it's negative.
X square minus y square.
What was saying negative?
For
the question is negative.
It wouldn't be possible. We did it.
Yeah, it's negative. I think that may copy back. May copy back now. But I hope from the question I wrote for you, it's negative. All right. Oh yeah, sorry. And I was also trying to get them before I see. All right, thank you. So that place will be u y squared equal to du dt over so now s ds dt over you can factor u out, right? So we get what? The x square minus
Y dy.
the numerator.
Yeah, omitted the one.
Oh, plus a plus
Yes.
Plus
y
dy.
dy dt. Alright, so yeah. We are getting
So
into this.
ignore the y dy.
Always this same principle will work in any question. One is going by the first one to get C1, and the rest, yeah, just focus on where the x and the distance is. Then this by this by this. You don't have anything else. But when we are, it just anytime first introduction of a concept is easy.
One break.
All right.
One
So
break.
this
One
this
plus y dy dt now.
plus one is.
Dy.
What's up for your time? Oh. Didn't answer my question. I know what is our question.
That's great.
Okay, right. So now we are two to go. So we have s du s ds over t plus y dy over t is equal to du over what? You now see, we are having the what is that?
Negative.
We are having now compare this one to the first one. Is it the same? You see, it's not the same. Here there is no u there. They are not the same. So go by the same way that we used to do the first one. Instead of using here equal to 0, integrate, bring a d, that's all. Integrate both sides. Go by the same thing. It's not the same thing. So s ds dt plus y dy dt minus du dt equals to 0. But this is just easy. If you are saying that this one is too long, yeah, then when we get to second order.
I'm so prepared now.
When you get to second order, yeah. When I second order, you get to the before you do the general equation. Before you can find any general equation for a second order, you need the canonical form to convert to ODE. And the canonical form generating only that is even Rishi.
This is the problem.
All right. So from here, like I said, Shabala is going.
Oh.
Sorry. The concept in formula two. First one, you know it. Second one, you know it. That's all. It's just algebra, but the same thing. Just algebra. And when you read this place, as I said, focus on the function x. Integrate x, what will you get? So just write d over dt of that result. Like that. 10 by 10. My video, that one place is say just one question. So we are going to get our beautiful C2. Then we do the same thing. Combine. Please, can we move on? Can I clean? Okay. So d dt, this is the exact. Don't go and learn it yet. This is the exact. The Shambhala way. Integrate x, what will you get? X squared with just like that. Plus d, don't forget this. And don't show any integral sign there. Don't show it there. If not, the method is wrong. Because that place is not integration method. We are saying that this one, when you use the exact, It means this. When you're using the that, this means this. But the idea is that it's integration. This will be y squared over minus what is the sorry? What is the operator? So it will be UDT. The second one. Which one? DDT, not DDT. Hey. So what is this? The last one, this one. U. You see that? It's like this. Integral of U. Okay. Integral of one, not U. Oh. That's what my name is saying. Okay, so it will be U. Please don't say it will be T. To be U. The one on top, the one on top is the bottom. All that you are doing, you see, we integrate as respect to x, integrate as respect to y. You see that? And integrate as respect to what? U. Not the T. The T is not important. So, what we simply means is that what we simply means is that d u is equal to 0. So what we simply means is that the whole of this is a derivative function. Okay, the whole of this. This one was the derivative function. Now we are integrating to get a function back. So now we have the function back. Zero.
No, that one before it.
Take your time.
You have the concept. Even if I leave it for you, you can do it. So now, this is like taking the derivative of 2 as respect to x, and you say it is what? So this is the function. Okay, this is a function. So this is a function. So we're going to do to get there. So let's integrate both sides. So what I'm going to get? X squared over 2. Yeah, it's not linear over there. You are going to combine. Just go by that. Y squared over 2 minus u is equal to C2. Make you the subject, but you know that is or without no, it's not about making you the subject. Let's tell you that. Yeah, we can simplify this function. You know we can simplify it. We can multiply 2 by 2. We can simplify this. Yes, multiply 2 by 2. And you're going to get 2C2.
Yes.
But it's still a constant.
But 1C2, not 2C2.
We are going to let.
So yeah, we are going to get multiply 2 by 2. You get x squared plus y squared minus 2u. You are multiplying 2 by 2 equal to 2c2. But the whole of this is still a constant again. You can say that let C3 be equal to this, but to bring C3 into something else. So it's still the same thing. C2 is equal to x squared plus y squared minus 2u. Now, go and combine and get your integral equation. That's all. That's all. It's all about getting the C1, C2 combined. The rest is still the same thing. Yes, the P will come in. The P, the M1.
Let's have them.
Remember, sir. Okay, so what is C1? What is C2?
X squared plus y squared
Minus 2u. So now here is what Mr. Ali was saying. Now looking at this, C1 Jew is in, C2 Jew is in. So what do we do? Any of it. So you can actually here the one that you choose to be in terms of the G depend, because you are given coach. If you are to solve for general equation, no problem. You are given coach, but let me summarize it. Here's what is going to happen. You know you can use F or what? Capital G. So here will be what? C2. So it means that we are going to get S y U is equal to C2. What is
S square.
S square plus y square minus 1 to U. This is the general equation to adapt, but we are given coach. So what is the coach? The initial condition.
There's no initial.
Oh, I get it. Then the initial condition is U S comma 3 X. You see? This is another reason why we said let's fix 2 meetings within a week.
To get a time crack.
I don't think today I can move on to the week. I think we have to establish this one mistake. It's very important. There are not. That's why I get to be in the small. Okay. So now U is what? S square. S is what? Oh, first order is small. It's like you are doing OD. It's like when you're doing OD, please go for the substitution. It's like when you're doing OD. Now, go for the substitution and see what goes happening in the inside there. Don't forget that the U is in terms of X, the S is in terms of S, Y is in terms of S. So the whole of it should be in terms of S. Go for it. It's like when you're doing OD. When you get to exact, depending on both and the rest, OD is very difficult. But when you get to second order, higher order, power series, I need exact question. I want exact question. That's how it is. The more you go, the more it becomes. But it's not difficult. Once you are here, you will take time to explain.
So the answer is 3x.
So now, let's do the substitution.
I will take my money next time, then I will come and pay.
Please here also
I will
the
get
substitution.
to buy something.
You don't mean that. Please the substitution. You don't do only the side of both. Yeah, you answer in the whole of it. So wherever you see. So here is X. Here will be what? Y is what? 3X. U is what? S squared. G. S is what? Y is what?
3x squared minus
Hold on. And U is what? S.
2x.
Oh, what is it about the 2x squared? Combine and see what you get. But based on this concept, even when you go to class, you feel free because you have the concept. You have to print this and move on so that you can capture to where we will be next.
I'm doing something in the bracket.
So what are you going to get here? 3x power 4. G, what is going to be the answer? 8x.
That is 2x squared. I will say.
Now even this is what?
8x squared.
8x squared. You are even we can learn this more algebra. Algebra again. Other question do what? Only Papa. Okay. So what is going to be?
Let's let the p be the 8x.
What is going to be? So if you let p to be God's side, 8x squared. What is p? What is going to see?
We make s squared the same.
What is going to be x? So what is going to be x? Square root of p over 8. Now, please let's watch something. Please let's watch something. We are going to do the substitution back to this, right?
Yeah.
We are going to do the substitution back to this. Everything here is in terms of x, and x is this. But don't forget, here is what? There is algebra here. Here is x squared. Here is 3x power 4. But 3x power 4, we can also leave it in x squared. This is the same as
Yes.
I hope you can see. I'll tell you the reason why I'm doing that. 8x. So now you can see x squared, right?
So let's make x squared.
So with this,
Let's make that one x squared.
is that, and that's why I'm coming back. You said this will not be. So here,
S squared is
very good. So here, just say that x squared is equal to p over 8. So that it will be simple. Oh yeah, someone can also use the square root to the same thing. If only you want multiply. So 3 p over what? 8 all squared is equal to g of 8 What can you see? The reason why we did this algebra. This cancel this. So we get g of p to be equal to, don't forget what we have been doing from linear coming. After every substitution, you get the p, then the g of p. So now we get g of p to be equal to what? And now that we have g of p, they went to cancel. You see that? So now that we have g of p, you just have to go back. Is the focus here or here? Please watch the general equation. Now, anytime we are doing this substitution, that's why the question that we are trying to find it difficult to apply our answer. Like, probably the one that you discussed. After getting the general equation, please take note of the general equation well. Because after everything, that's where you come. So if this is the general equation, and now we are having this, then the work becomes simple. But the question is the focus here or here? The right answer. The right answer. Then that's all. You just copy the same thing. So the particular solution, is going to be x, y, u. No substitution there. Don't forget that the particular solution is supposed to be in terms of x, y, u. And after that, you can make use of it. So the particular solution is going to be x, y, u. We are copying. But we know that the g of, like I said, this substitution that we did is the same as p is equal to this. Like I said the other day. So that p that you see here, that p is still the same as what? So this p is the same as what? S squared. S squared. It's like I'm doing substitution here. Or if you can see, just quote this. When you see p, put what is there and 1. So 3. Then you go back. It's this. And this is defined as this. So quote this. When you see p, then you put that there. So x squared plus what? Y squared minus 2u. All this over 8. Or this is the general, the particular equation. That's all.
So the 3 is bracket p by square.
Yeah.
Yeah.
You agree on this?
Yes.
Now you substitution here, then you get this. See, understand? Is it working out? You can try to do substitution here. Before you even come to this, watch. What is p? What is p? This is a composite function. X squared plus y squared minus 2u is equal to 3. So this means that wherever you see p, put 1 there. X squared plus what? Y squared minus 2u. All this over 8. And what is this? So after getting this, we just do substitution here to the general equation. The general equation is always the focus. Please hope you are getting it. You can do it that way. It's still the same thing. Because this is defined. So just have. And that is the final answer for that. So let me give you one to try. Right now. Then we move on. Okay?
It doesn't necessarily mean that you make it necessary.
Oh! No, for that one it's not necessary. You know in PDE or OD, we have many solutions. So anyway you leave it, it's a solution. It's a solution. Hey, if you are going to make this you the subject,
How do you choose between the two U's? How do
I choose between
the two U's? How relate one to the other?
How relating one to the other?
Because both contain U variables.
Yeah, that is why when you're doing the substitution, you do for all. You do for all.
Or you come for between the C1 and the C2.
Okay, I'm not getting it. Somebody is asking, how do I choose whether this to be inside or this to be here?
You relate one to the other.
Any of it that will go back to work. Because watch, at the end, you are going to get, if you try to put this one outside, this one inside, at the end, you are going to get 8x squared is equal to g of what? 3x to the power 4. And then we say p to work for this. Your p will be equal to this. You get the same thing. But your particular solution will be different from mine. But it's the same thing. because in PDE you get many what solutions, infinitely many solutions, because your final answer, your final result, your own, this one will come to this, and maybe this will come to this, something like that. You can go and try. Yeah. So, all right. Let me give you one so that when you go there, you try. Why calling for the same thing? Please, let's solve one question here. Let's solve one question here. Because, but with this, our wrap up. The first question, introducing. All right. Here, we are just going for the general equation for x. U subscript s. Oh, grab the concept. If you grab the concept, the model. What type is that? What type of characteristic equation is that? Question. This was a question I received for sure. I go my way. Okay. Oh, sorry, let me check that one. Yes, that's how it is. Yes. Yeah. That's how it is. No, I need no question. So that's where I so that you have to be careful when checking the question word. So it should be SU. So you can do this. You see that? Oh, I'm just
Subscript
that place is why. Well, so quick. So, what is A? Yeah, stop, man. I want you to stop. This type of things is like if you don't get a boldness to be solving questions, you will always stick to already solved questions. You will always stick to already solved questions.
No, first question, I cannot answer. I want a question. I do the question.
Hey.
You and your student.
Please stop. It can be X question. So X, Y. What most friends should X, Y? Okay,
you can decide to also do it.
It's algebra we agree. Yeah. So yeah, you form your. And looking at this, when you pick this and this, you may not. And so let's go for the easiest one. And the easiest one is the first and one. Like sometimes I want to see you working so that I see that you are looking good. And somebody is asking why not the DT? You see, in the linear, when solving linear, you can bring DT. You know you can bring DT. But sometimes you don't need form easily. That's why that place you don't bring DT. So if the thing is forming easy for you, don't go for it. But you can bring it on. So like say you say you should multiply through by
S1.
S1. Or this move to this side. This move to this side. Separable differential equation. Separable differential equation. Element can't let them do to that. We will quite remember. Separable. Please, let's go. You have forgotten the OD. Let's go for the OD. Very simple. Let's simple. We are voting for the result too. Let's wait for it.
This one
Bandura, you are still waiting.
I'm putting my shoe on. I'm putting my shoe on.
Now you can say you go out.
Hey.
So you have negative y, yes, s, y. But now see, this is still not separate because why can you integrate y and the operator is what? X. So you need to still go back again.
Yeah, bro, but it's already separate.
Yeah, you only multiply 2 by you. Then you have
It's already separate.
Yeah.
It's already
Multiply
separate.
2 by you. Even you apply
It's separate.
you can just multiply 2 by you. Because the operator here is y, and y is here. Yes, S is here. So it's only the u that is behaving. Papa, what is your
This is the way to love. I leave book did here.
See, if the concept of multiplication equation you can clearly see that. Because you just take inverse of both sides. So here will be 1 over x dx. You see that? Inverse of both sides. Then here will be 1 over y dy. But we should know whether I end up solving them. Let's get a concept. So yeah, you guys see it. Yeah, yo, negative g x. You can negative both sides. Negative, don't worry. Negative here.
The solution is the
general one will be the same. From here, the solution can be different, but the general one will be the same.
Also, one negative number would be different. Then we generate
So there is a concept we can bring it here. You can bring the list here anywhere. So here it will be lane c over x equal to lane y. Then we take the natural log of both sides. This one is easy, but the second one so natural log of both sides. C over x is equal to y. So we are going to get C1 to be equal to S. Leave it. He's saying that the first one, the beginning when they come you. Please, let's get the concept. Yeah, let's get a concept. And not that even time you are solving crazy, it's supposed to be. But you know that thing that we apply It's because that we can't see the ODE straightforward like that. So we have to, so we have to go for the what? The algebra thing. You see that? Now you see the ODE, simple, but go your way. Otherwise, you don't bring this. Sure. Now, let's go for the second one and see what is going to happen. Let's go for the second one and see what is going to happen. Now, the second one. Then, let's go for the CT. Second one. With the concept we applied, one is going to work here. Which one? Check what? Now, see, the OD is not working, right? Whether this or this or this, the OD is not working. Let's agree on this. It's not working, so that the concept is clear. It's not working. It's not working. If you pick this and this, you can't work. This and this, you can't work. Then, if it can't work, and here too, it's not about 1 over. It is not about 1 over. Please, how you guys see that? It's not about 1 over. How you guys see that? You understand me? Yeah, it's not about 1 over. Then the only thing that is going to help you is the algebra that A over C equal to what? C over C. Then you issue the equivalent statement. This. But this is class of minus. Yeah, you can add or what? Subtract. So if the OD is not working, then what for? So please, the critical analysis begins. Let's watch. Please, are we all watching? Let's watch. In the first one, we said that we want to get something so that when we add, because we want to use that algebra, and it's about adding or what? Subtracting. So when we add, something will cancel. Yes and yeah. The reason why we are multiplying s over s, y over y, and we want it to be the case that when we add, something will cancel. This is how we can see that. And look at something here. What is this? What is the sign there? Beautiful. Now tell me. Okay, I'm going to emphasize. I'm going to combine this. But I want to use it, but should I combine this because we have already used this? We have already used this and this. So it's whether this to this or this to this. And now watch. Since we have s squared here, which one is going to help us? The ds over su. You want to do something. What thing is that? Go for it. Go for it. So you can see that here we have to multiply. You see that? We have to multiply here by what? 1. Do the same as s over what? X. And here will become what? S squared u. And when will you go for adding or subtracting?
No, you subtract.
We need to also send a u to the
No, we are there.
It's true. You see that now the contract is coming. The reason why we are sending now it is coming because for this to combine for the s squared to cancel, this have to go up. Yeah, you want to talk.
You can see that the one at the far right hand side, that the y squared minus x squared. You can see that one is a difference of 2 squares. Right? So when we add the x over x cubed and then the dy over minus y, we get the x plus the y over x cubed minus y. I don't know if that one works. Then we factor the u out. So we get x minus u for 1 factor.
Why not? It will work. I was even, the same way, if multiplying this s over s making it s squared, we can multiply here 2 by what? Y over what? Y. And this. We can combine factor and get the same thing. That's why I'm saying that the concept is what matters. The concept. The concept is what matters. Because here, now we are going to get what?
To see it at the same time.
Y over y, s over x. Like what we were doing at first. And see, that's why you get it, you have to open your eyes because of the UPS. Like what he's saying, let me emphasize on you. You can say the U up or you get one over you on top there, right? But
You make any choice.
I realize that
Yes,
it will work. But sometimes when somebody is making suggestions, you have to get
you manipulate.
see, if you send that one over you there, then you check, is it going to work? If you say that because for that one you won't include this, let's talk about that before. So that the concept will be clear. Let's include everybody's idea. Like what say is saying, we should bring one over you here. So like you want to focus this and this only to ignore this. So to be 1 over u dx all over what? So now here is going to be s squared. So remember what is for me here? S over what? S over u. That one is going to be a problem.
The other side was going to be a problem. X square, y square.
That one is going to create a problem. So even though you are seeing that this, when we add, this and this will cancel all right. But it's creating a problem here. So anytime that we are applying that s square, you need to apply to the other side. This is how we are watching. Anytime that we are applying this concept, you need to apply to one also. It don't apply for only one. It don't apply for only this. Then you combine with one thing. No. Whenever you are applying that, open your eyes. It will work somewhere again for you to. Please help me understand what I'm saying. So it's good to get the idea that when you bring s over x, then when you get s square here and s square is here, when you add it will go because you say the u out. But when you say the u out, what will happen? So always when you apply that, include the other one you want to do. Because that's what it's going to get. Please, I hope the concept is clear. In fact, after these two questions, you can solve any question. Okay, so here, s over x times y over, don't forget negatives here. So let's go for it. So here we get s dx over s square u. Plus, because the negative is negative y dy. Like somebody saying, you can bring dt or not. Then what will happen here? Minus y squared u. S squared.
Then the top one minus y divided.
The top one. No, the negative is
No.
I say
No, this one. Because of what you said.
Take your question. It's not minus y, it's equal to.
okay. So here we are going to get s dx plus over. Beautiful. Now see, what is that? We can factor you out.
Yes.
And when you factor you out, what will you get?
S squared minus y squared.
S squared minus y squared.
Yes, like that.
Now, you will not do anything. Let's move on. So let's factor in. Now
We can send it. Yeah.
you can be sending it like they use the focus.
Some people are
Yes,
man.
or you can say when you multiply 2 by root 2, it will work. I hope now I can continue. Now, you can see that in the top here, it's forming something that's exact what? Differential equation. Depending on both what? X and what? Y. But like I said, you can use several ways. So watch. Yeah. Oh, let's factor out first. So we get S, yes. Let's do it since you have it. Now we can factor the S out, the negative out. Clear.
Why do you take negative so that we get the
Mass is mass. He said that. Why don't you take the negative u? Yeah. In the same way, multiply 2 by negative u. So x dx, y dy, then you will be negative u over and this exact differential equation depending on both x and y. But yes, still we can do something. Even if you are forgetting your exact differential equation depending on both x and y, you can do something. And what is that? Watch. Like that. You factorize. So now watch. Oh, this one, let's get it. Our time is over now.
Bro.
Oh, okay. Oh, but what we wait not so. The understand is what matters. So we have S, DS, plus.
need backup.
Beautiful. Please help you are watching. Now, from here, what will you do? Integrate. Can you wait? Oh yeah, we can. So yes, x yes plus u d equal to, and you can integrate x. Go for it. I have told you, don't issue any integration sign. Don't let the examiner know that you are using integration. But you don't want to. So you have one of the two x. Hey, but you know.
You can go in.
Okay, so from here, the same way like the first one. You get you get your C2. So now you have C1. Your C1 is P1 is C1 is F1, and you have C2 is that. So you just combine. Which one is the term of it? C2. So it's supposed to be C2, G of what? C1. You see that? Then, there's no approach, so you go for the general equation. That is that. Thank you.
Yeah, this is my